Welcome back to our Math 171 video series. In this set of videos, we will solve a higher degree polynomial. We're going to begin with this new polynomial, which is fourth power, 2x to the fourth minus 13x to the third minus x squared plus 9x plus 3. We're going to first find all of the possible roots for this polynomial, and then we'll use Descartes' law of signs to find the possible positive and negative real root numbers. To use Descartes' law of signs, we will look for sign changes in the coefficients of this polynomial. To find the number of positive roots, we'll look for the number of sign changes in the polynomial as written, and to find the negative roots, we're going to look for the same thing, except for we're going to change the signs on any of the coefficients that have odd powers of x. We'll begin by writing down our polynomial first. For our positive roots, we'll start with 2x to the fourth, which is positive. We'll have negative 13x to the third, which is negative. Negative x squared, which is also negative. Positive 9x, it's positive, and then positive 3. We can see a sign change between the first positive and that negative, and then between the second negative and the second positive. Therefore, we have two sign changes, which means we could have up to two positive roots. However, remember that some of our roots could be complex roots, and those complex roots come in pairs. So I could have two positive roots, or I could have zero positive roots with two that are complex. For the negative roots, we'll do the same thing, but we'll change the sign on the coefficient of the x to the third, and change the sign on the coefficient of x. Any of the odd powers will change sign. Therefore, 2x to the fourth is still positive, but we'll change the negative 13 to positive 13. We'll keep the negative x squared negative, but we'll change the positive 9x to negative. Then the constant term 3 is not affected. Therefore, we have two sign changes that I'll mark between the second positive and the first negative, and between the second negative and the third positive. Those two sign changes tell us that we could have up to two negative roots. Again, some of these could be complex, so we could also have zero negative roots. Based on that, we'll list our possibilities. It's possible that we could have two positive roots and two negative roots. Remember that our power for this polynomial is fourth power. If I have two positive roots and two negative roots, that adds up to 4. Meaning I would not have any complex roots. This will be possibility A. For possibility B, let's imagine if I had two positive roots but no negative roots, that would leave me two complex roots. The two positive plus the two complex would still give me a total of 4, and that matches my power. Possibility C is if I have no positive roots but two negative roots, which would also leave me with two complex roots. And possibility D is if I have no positive or negative roots and 4 complex roots. We don't know yet which possibility we're going to have, but we'll figure that out in the future parts to this set of videos. Now, to find the possible roots, we will look at the factors of the constant term and factors of the highest power term. My constant term in this polynomial is a 3, so we'll look at factors of 3. My highest power coefficient is 2, so we'll also look at factors of 2. My factors of 3 are 1 and 3, because 3 is prime. My factors of 2 are 1 and 2, because 2 is also prime. Now we'll take our factors of 3 over all of the factors of 2. My first possibility will be 1 over 1 because both of the terms have 1 in them. 1 over 1 will give me 1. Also bear in mind this could be plus or minus 1. However, I could also have 3 over 1. Therefore, I can say plus or minus 3 will be another possible set of factors. Now I can do the same thing, but now divide by 2. So I could have plus or minus 1/2 and plus or minus 3/2. I will separate these into separate lists, positive and negative. I'll also write them in order. My positive possible rational roots are 1/2, 1, 3/2, and 3. I'll have the same roots for negative, -1/2, -1, -3/2, -3. These will be my possible rational roots. In our next section, we'll begin using the process of elimination to try to cut this list down.